Odds ratios, what are they and how do we interpret them in data analysis? In this video, we're going to discuss the concept of odds ratios and how we interpret them or how it's important in data analysis. So odds ratios is a measure of association between an exposure and an outcome. And it compares the odds between an event occurring in one group to the odds of it occurring in another group. So we are looking at what's the odds of an event occurring in this group A divided by the odds of it occurring in another group, let's say B. It's commonly used in case control studies, logistic regression, and epidemiology. So how do we compute odds ratios? In short, in a nutshell, we compute odds ratio by comparing. I have a 2x2 table here where we are comparing exposure versus outcome, and AA is exposure yes, outcome yes. B is exposure yes, but outcome no. Then C is exposure no, and outcome yes, and D is exposure no and outcome no. So in order to get the odds ratio in this instance, we'll say A multiplied by D divided by B multiplied by C as shown here. However, in logistic regression, we saw that in logistic regression, we are able to model our equation given by P over 1 minus P, which is equals to beta naught plus beta 1 xi plus beta 2 x2 and so forth. So in order to get the odds ratio for the coefficients of beta, we'll need to exponentiate each beta. For example, beta naught will say exponential of beta naught, exponential of beta 1 and so forth. But how do we interpret? When we get odds ratios equals to 1, this means that there is no association between the exposure and outcome, and that the odds are the same for both groups. So the odds of the event occurring in group A is the same as the odds of the event occurring in group B. But when we get odds ratios greater than 1, this means that exposure increases the odds of the outcome. That means that there is higher or stronger OR. The higher the OR, the stronger the association. So if we get odds greater than 1, we'll be saying that the odds of event occurring in group B is greater than that occurring in group A by this much. When we have negative OR, that is now negative association is indicated by OR less than 1. And this means that the exposure reduces the odds of the outcome, and it could suggest a protective factor. So we'll be seeing an example in the next slide. So in this example is what we covered in a previous video, and what we have here, we were trying, the event of interest was whether a patient has diabetes, yes or no, based on several characteristics or several predictors such as gender, age, smoking history, and so forth. So we are going just to explain the multivariate section of this table, and we'll start with the one for gender. And what it shows us here, we have a odds of 1.3 male. So what this means, how will we interpret this? So given an individual is a male, the odds of them experiencing diabetes increases by 1.3 compared to females, and that odds ratio is significant. What about heart disease? So individuals with heart disease are at 2.0 times are at 2.03 times risks, or their odds of getting diabetes are 2.0 times compared to those without heart disease. When we have an instance of BMI category here, where we're having underweight individuals having 0.57, how we will be interpreting this is underweight individuals experience are at 0.57 times less risk of diabetes compared to those who are normal weight. Alternatively, you can use percentages, but for this video we're explaining with using odds ratio. So in a nutshell, odds ratios compare exposure between one group to another group, the odds of this group experiencing the exposure outcome compared to another group. And odds ratio, when it's equal to 1, it means there is no association. Odds ratios when are greater than 1, it means that there is increased risk. And odds ratio below 1, it means there are decreased risk. If you enjoyed this video, give it a thumbs up and share it with your friends. Thank you, and I'll see you in the next one.